Hello, good morning everyone. Today we're going to visit Hong Kong Global Geopark Volcano Discovery Center, located at Saigon Seafront Park. So this center will provide a lot of information about volcanic process and volcanic rocks. So let's check it out. Go inside. Okay, let's start to introduce the four scenarios of volcanic eruptions in Hong Kong. In 165 million years ago, so the first episode of volcanic eruptions happened in the north part of New Territory, followed by 148 million years ago around the Lantau Islands, 143 to 142 million years ago around Hong Kong Island and Saigon area. So the last episode of volcanic eruption is 140 million years ago around the Saigon area. So this is also the purpose of our visit today. So the volcanic eruption around the High Island Reservoir actually contains a large area around 18 kilometers from north to the south. So you can look at this model built up here from the High Island Reservoir. Here is the Hong Kong group, many small islands, all the way to the south for Nanping group, the island here. So the Sharp Island, today's visit will be around the edge of the big caldera. So let's look at this. Okay, this is a beautiful model showing the columnar joints, which was formed during the cooling down of volcanic eruption, lava flow. So you can check it out. This is a beautiful rhyolite volcanic rock. It consists of materials which cooled down from the volcanic ashes and lava. This is a model for the Sharp Island, today's site of visit. Actually, the Sharp Island is located around the edge of the caldera. It has various of volcanic rocks like quartz monzonite, volcanic breccia, and rhyolite. So today we're going to see them all. Okay. So this model actually shows the extent of the volcano activities in Hong Kong in around 140 million years. So a 2012 CEDD study on the High Island ancient supervolcano found that the extrusive part of these rocks actually concentrated around the Saigon area. So this is called caldera. Caldera is actually the broken volcano. So when the mass underneath is erupted out, so the ground will become hollow. So the ground sinks down and form a very large caldera area. As I just mentioned, the size is around 18 kilometers. And also another interesting findings from this study is that the intrusive part of the rock that forms the magma chamber was actually spread all the way to Hong Kong Island and a part of Kowloon. Now let's talk about volcanic rocks. Here is some examples of volcanic tuff. Volcanic tuff consists of consolidated volcanic ash with a grain size less than 2 millimeter. So we call it volcanic tuff. Here's another example. So they are basically lighter colored, have the same mineral composition as the granite. So they are felsic rock, or we call it acidic rock. And also has the same chemical composition as the rhyolite. Let's check it out here. This is called scoria. Scoria is a pyroclastic, highly vesicular, dark-colored volcanic rock that was ejected from a volcano and cooled in the air. You can see very fine crystals and a lot of holes and bubbles. We call it vesicular structure. So follow the injections and depositions. This volcanical ashes actually cool down, become a part of a rock. Now let's look at the basalt. As I explained, the basalt is made by the darker minerals. So it contains some ferromagnesium minerals, and we call it a mafic rock. So it's due to the rapid cool down from the volcanic lava flow. So another mafic rock is called Gabriel. Here is one example here. So it's made from basaltic magma, but it's intruded below the ground and cooled down slowly. So you can clearly see some larger grains actually show up, but generally it contains dark minerals. So let's move to the intermediate rock, namely andesite and diorite. So here is an example of andesite. So it's intermediate rock, so it has both composition of felsic and mafic minerals. So because it's extruded from the volcanoes and cool down rapidly, so the grain size is small. Let's move on. Another intermediate rock is called diorite. So it's made from intermediate magma, intruded below the ground and cooled down slowly. So you can see the grain size is much larger. So another example of andesite again. So the felsic rock, as I show here, we will have intrusive rock called granite. So here is an example of one granite. Very large grains, relatively lighter colored because of felsic minerals, feldspar and silica rich. And here is the so-called rhyolite. The rhyolite is made from acidic lava called felsic mineral and extruded from volcanic eruption and cooled down very quickly. So it has fine grains. So besides this, and also we have pyroclastic rocks, which is made from volcanic eruptions. So for example, we have a very good example of obsidian here. Obsidian is actually volcanic glass, we call it. It is made from acidic lava that extruded from a volcano and cooled down very quickly. So the grain size is very fine. It looks like glassy now. This is a beautiful piece and very hard and brittle. So another example I can here is so-called agglomerate. Agglomerate here. Agglomerate actually has large coarse rock fragments associated with the lava flow that are injected during explosive volcanic eruption. So this is another example of agglomerate. You can see the coarse accumulation of large blocks of materials. So I have to emphasize that this agglomerate is different from conglomerate. A conglomerate is sedimentary rock. Agglomerate is volcanic rock. They are different terms. So another interesting one is so-called pumice here. So you can see pumice is actually highly vesicular, okay, highly vesicular. Actually, it's typically lighter colored, contain a lot of small bubbles, which called a vesicular structure. Because it contains so many bubbles, so it's lighter than water, so it will float on water. In Chinese, it's called 浮石, the pumice. They're all pyroclastic rocks. So this pumice actually is lighter than water. So if we look at here, scoria also contains a lot of bubbles, but it's denser or heavier than water, so it can sink down a little bit more heavier than the pumice. Okay, let's take a round for more interesting stuff. Okay, here is a very interesting task to talk about the viscosity of a lava flow. So you know the lava actually contains different type of minerals, especially the silica content actually determines the viscosity. When it has less silica, actually the viscosity is very low, like a basalt. The basic rocks. So when the silica content actually increases, magma viscosity increases as well. For this one, you can see it. This one has the highest viscosity. So in Hong Kong, actually rock are mainly acidic rock. Basically contains a higher concentration of silica. So the viscosity is pretty high. In the contrast, if we have basaltic lava, so the viscosity is rather low. So this is an example from Heilongjiang. A less viscous lava flowed out. Here actually talking about the pyroclastic rocks. We're mainly talking about the materials ejected from volcanic eruptions. Depending on the grain size, we call it, for example, volcanic ash, so which the particle has the size of smaller than 2 millimeters. The wind can scatter the particles around this area and settle down into volcanic tuff. So when the particle size is a little bit larger, we call it lapilli. Lapilli is a name that means little rock. So you can see the pieces of particles are from 2 to 60 millimeters in diameter. If it's even larger, we call it volcanic bomb. So this is an example of fragments of volcanic bomb from molten rocks. It's more than 60 millimeters in diameter, ejected from a volcano. Let's play around this. That shows the tectonic settings of volcanic eruption. So this is example shows a subduction slab, subduction plate. So every year it moves downward. So the materials will be carried down to a deeper ground. So when the temperature and pressure change, and also release the moisture actually changes the melting point of the ambient rock. So it called fluid-induced melting. So the magma will be generated and rise to stay at the magma chamber. So when pressure is large enough, it will find the crack and goes up through the volcanic wind and blow up, flow down as a lava flow. So you can see the different places you have different temperatures down to the continental crust, the mantle part, so more than 1,200 to 1,400 degrees. So when the lava erupted, it's also very hot. It's like 700 to 900 degrees. So this is a very good model to illustrate this part. Now this is a kind of very interesting expression of columnar joints, hexagonal rock columns formed during the volcanic eruption. So actually we have a field trip to the higher end of the reservoir, explain the situation. In the violent eruption 140 million years ago, so the ground actually sank down, formed caldera. A thick layer of volcanic materials actually accumulated on the ground. When they cool down, the material will contract, and due to this contraction and generate cracks, and the cracks will propagate it downwards to form columnar joints. So this shows the size of columnar joints. So you can see it's very big, about 1.5 and 2 meters. Some places can as large like 3 meters. So the Hong Kong's hexagonal rock columns were unique. Why CS? Because most rock columns around the world are composed of dark-colored basalt. They are made by highly viscous lava flow. While the minerals of Hong Kong volcanic rock, or the lava flow, actually has a higher silica content. So it's hard to accumulate, hard to flow in such a large scale. So this long, thick columns actually is magnificent and quite unique in the world. So let's check out other basaltic columnar joints in USA, Wyoming, in Ireland, in Greece, and also Korea. All right, so I think this is a very good tour of the Volcanical Center. Thank you very much. Coming out from Volcano Center, now we are at the Saigon Public Pier. We're going to take a boat to the Sharp Island for the field trip. Let's go together. Enjoy the ride. It's a beautiful sunny morning. Very shiny, good weather. Okay, now we are approaching the pier. We're going to land the Sharp Island right now. You can see in the far field, that is Hong Kong University of Science and Technology, HKUST. You see the tumbaloo actually connecting the two islands. Right now is a low tide. Probably we can also walk over there. So we just landed the pier here. We're going to walk around to see the volcanic breccia and also the rhyolite. It's a very famous rock. It looks like pineapple. And then the tumbaloo will connect to a smaller island here. So the whole trail is about 2 kilometers. We also walk over here to look at the rhyolite. So here is a brief introduction. About 143 million years ago, this place actually is close to the volcanic eruptions. Precisely, it's located on the caldera edge. So volcanic breccia is formed by cooling and solidification of rock fragments, very large blocks, and also volcanic ashes and lavas ejected from volcanic eruption. For the rhyolite, actually rhyolite has a flow banding formed by high viscosity lava. So it shows the flow patterns and also shows that Sharp Island once set on the crater margin of ancient volcano, as I mentioned before. So we're going to check it out. Okay, so let's go together. In this place, we can see a lot of volcanic breccia. The so-called volcanic breccia is formed by a larger stones from volcanic eruption. But clearly you can see the large green size, and you touch it, it's pretty rough. So that's why we call it breccia. So this is more than 2 centimeters. This is even larger, and also contains more. So the whole ground is pretty rough, so be very careful to walk on this irregular surface. So you can also see quite a lot of joints, which is running in the different direction. For example, this is one joint. This is another set of a joint. For here, you can also see the joints. Let's walk around. You can see this irregular pieces. So all these large blocks actually were ejected from volcano eruption. This remain here and generally fractures joints and get weathered during the time. So let's go to the beach. 11 o'clock in the morning, there are already some family gathering here, and also somebody is working on the boat. This is the most famous spot on the Sharp Island. Look at this rock. If you look around it, what does it look like? It looked like a pineapple bomb. Indeed, we call this is bo lo bao in Chinese. So what is this rock is made of? Let me explain to you by using this graph. As we mentioned, 140 million years ago, the volcanic eruptions around Saigon area. So the volcanic ashes will generate volcanic tuff, and the lava flow on the ground will become rhyolite. Deeper inside, the magma chamber could also cool down. It become intrusive volcanic rock. Here are labeled granite, and another is quartz monzonite. The quartz monzonite is exactly the pineapple bomb. So what's the difference of this type of rocks? First of all, the all-intrusive igneous rock. We call them granitic rock. But relatively, they have different compositions. The granite has 35% of quartz, 50% of feldspar, while the quartz monzonite has less than 20% of quartz, and plagioclase and alkali feldspar add together more than 70%. The remainings are biotite mica and hornblende. So this is a fresh example of this quartz monzonite. So relatively speaking, granite takes 80% of all this igneous rock, intrusive rock, and quartz monzonite is relatively rare, only 5%. Let's look at the minerals. You can clearly see here, we have this rectangular white mineral. This is plagioclase feldspar. Another type is this pink colored. They are alkali feldspar. You can also see a little bit about quartz, and a little bit darker spots, they are micas. So this rock is relatively similar to granite, but slightly different composition, so we call it the quartz monzonite. So how the quartz monzonite actually become a pineapple? Due to the weathering. The wetting and dryings, heatings and coolings will generate cracks on the surface. So the cracks will develop around the rock, so it's become rounded. So when the weathering progress, you can also see some become rounded. This does not look like a pineapple bomb anymore, but they are the same type of rock. So let's walk around here. There are quite a lot of these pineapples. And also another important rock here, this one. This is so-called rhyolite. So you can clearly see the flow bandings. They are extrusive volcanic rock due to cooling down of lava flow. So when the lava actually flows, they leave kind of a banding structures and show the flow path of the lava flow. So this is a recording of the lava flow process. It's a very beautiful rock. So you can think about it, the mineral composition of this rhyolite. All right, this is another excellent piece of the rhyolite. You can clearly see the flow banding here. Wow, also look at here. Okay, let's go to the Tambolo, to that island. Tambolo is a sand beach actually connecting the two islands from here to there. So if the tide is higher, so the whole path will be submerged under the water, so you cannot pass through it. This is a path to go up the small hill. Yeah, I don't think we're going to go up all the way there, so let's look around, surround this island. Again, we see volcanic breccia. And also the rhyolite. After a long walk, we come back from the Tombolo and sit in the small pebble beach. So clearly, let me explain this quartz monzonite and rhyolite again here. So quartz monzonite is intrusive igneous rock, so it has larger grain size. On the other hand, the rhyolite is extrusive volcanic rock, so it has very fine grains. So rhyolite can be very beautiful in colors. So clearly you see this example here. Because of a slightly different in the mineralogies, actually gives lava flow a different colors. So when they cool down, they can form a colorful bandings. This is also quite beautiful. This piece has a slightly kind of a gray and yellow and even the red colors. Very colorful piece of rock. This is granite. Okay, the whole area actually filled with all these two types of rocks. Quartz monzonite, the rhyolite. Okay, let's walk along the other side of the beach. Now we're walking on this side of the beach. This location almost have no visitors. Okay, you can take a look. This piece of rock is larger than 2 meters. So you can clearly see flow bandings and different colorings. Brown, yellowish, gray colors. This is a big piece of rhyolite. Well, this one, a beautiful piece, shows a curvous flow path. Very large and beautiful. All right, this is the end of today's field trip to the Sharp Island and the Saigon Volcano Center. So I'm Professor Gang from HKUST.
This is Matthew.
This is Riley. This is Yvonne.
Hope you enjoy our trip together. See you next time. Bye-bye.